Thank you, Yoki. Well, that's the first thing I'd like to say. Well, during the opening ceremony, they got my information wrongly. So, I'm working with Rajshri Hospital, that's the logo of my hospital, in the Ministry of Public Health. I'm not employee of Google. Well, but however, we are good collaborators. I had no financial interest in any products of Google, but we are very good collaborators. And we got a very good papers for our collaboration, and one of them, in which I'm gonna tell you at the moment. Well, this is my talk. I'm gonna start with the paradigm shift for treatment of diabetic macular edema. Back in the 1990s, where we used the early treatment diagnostic study, or TTDIS. Well, in that study, the indication of treatment is CSME, clinically significant macular edema, and we identified them using clinical examination on the standard photo, which is endoscopic, and we use focal laser treatment, and it can reduce the risk of moderate visual loss by 50% of patients. But now, in the era of 2010, we use the protocol I of the Unmet study as guideline. The indication of treatment is centered involve DME. And we identified these cases using OCT devices, not clinical examination or endoscopic photos of color blindness. The treatment is anti-VEGF, and we are able to improve vision, not reduce the risk of visual loss. We improve vision by means of 2 lines of vision. Well, there's still unmet need for managing DME because the result of the DRCR study for CI-DME, Center Involved DME, according to OCT measures. And OCT devices, they are not for screening DME in general populations of diabetes, and they are expensive, not practical in primary care settings. And they are not readily available or as ubiquitous as the Macular photographies. Now, in this paper, they try to compare the prevalence of DME based on Macular photograph and OCT. And here, I'm going to show you. If they use the definition of MISA, the DME and CSME, yes, here, this number, but it's no, a lot of no by the DME according to OCT. You see this high number here? And if you take a look at the prevalence of DME based on the color blindness and OCT, there's a difference between 40% in case of DME and 27% in case of clinically significant macular edema. So here are some examples. You can see the heart accident within the photocenter. You can definitely see, well, this is DME, right, from the color blindness photo. But for the OCT, you can see there's no center involved DME. There's no thickening here at the center. And here in this case, there's no exudation here at the fovea. But if you see OCT in this case, there's thickening here at the center. So this is CI-DME. Well, the prevalence of CI-DME detected by color blindness photography is different from those detected by OCT. My question is, can deep learning be used to predict CI-DME using OCT as standard from color blindness photography with acceptable high accuracy? This is what Lily showed you before. Well, there are 2 studies trying to answer these questions. This is the first study published in LBS from the Roche from Switzerland group. And here's our paper, accepted to be published in Nature Communications soon. Well, in the first paper, LBS, they used the Packer DR color blindness photo dataset and transfer the knowledge into the new model, which is developed based on the RISE and RIDE study, which is a randomized clinical trial. And they want to predict the central subfield thickness and central foveal thickness by the account of 15 microns or 400 microns. But here's our algorithm that Lily showed you before, where we use the data from OCT and to define center involved DME. And we use a center point thickness, and we manually measure each case of thickness by hand with guidance by retinal specialists, more than 250 microns at the point of cutoff. And we use the data for the CI-DME, as I showed you here, center point thickness, and the subfield presence or infrared presence with the corresponding color blindness photo to train the model. And we test the model with the unseen color blindness images And the prediction here is the prevalence of CI-DME and the presence of subretinal fluid and the presence of intraocular fluid. And here the comparison between the two papers that I show you. Well, the objective of the IOVS paper is to detect OCT measures of macular thickness from color photograph. But in our paper, we want to detect CI-DME, which is OCT based on the color photograph. Here's a population. This is the clinical trial population from Rice and Rice study. And they use treated and untreated images from repeated patients. In our study, this is from a referral center. This is from Thailand. This is a data from Thailand, my hospital, Rashpati Hospital. This is 4,000 patients, 7,000 images, and we use a center point thickness, and I told you. This is all untreated and no repeated patient. And the measurement here, the OBS study, we use trained personnel at a reading center, 40 to 50% of the CST and CFT is more than 250 microns, and they use time domain, which is all version of OCT. In our study, we use trained personnel, as I mentioned to you before, and 28% has a center point thickness of more than 250 microns, and we use a spectral domain OCT, which is later technology. For the eligibility criteria, they use the VCV eligibility criteria as well, because this is clinical trial, but in our study, we have no VCV eligibility criteria. And it includes cases with laser scar as well, but we exclude in our study. Well, there's no training for intraocular fluid or subretinal fluid in the IOVS study, and there's no internal validation. And for the validation, there's no comparison with the retinal specialist to grade the color contrast images, but we have all these in our paper. Well, this is the result from the IOVS paper. In terms of the centers of field thickness and the center of foveal thickness, I mean the cutoff 250 of 100, they are pretty much the same. Well, the AUC here for all the data subset is about 0.86 or 87, yeah, around here, yeah. But the best subset is when they remove cases with laser scar. The best AUC is around 0.97. It's the same either for the centers of field thickness or the center of foveal thickness. And here's our result. Well, the positive predictive value of our model is 61%. Well, when you compare to the retinal specialist, well, each of the retinal specialists has around 37%, which is lower than the model. For the negative predictive value, we got like 93%. I'm sorry, I didn't wear glasses, I'm sorry. Well, for the retinal specialists, they have like 88 to 89%. For the sensitivity, we have 85%, which is pretty much on par with the retinal specialists, 85 or 82% around that. But for the specificity, you can say that, well, our model have around 80%. But for the retinal specialists, they have much lower, 45 here, or even like 50%. For accuracy, we have 81%, but for the retinal specialists, totally they have like around 58%. For kappa, we have 0.57. For retinal specialists, they have like 0.2 something. Here the AUC, this is the for the model. Here is for the retinal specialists, but this is from the primary data set, the internal validation of our own data. But when we test with the external validation or the external data, where the proportion of CI-DME is much less than our internal validation set. This is only like 7.8% compared to 20-something in our data set. Well, the agency is still higher than the graders in the external validation set, although the agency is decreasing from the primary validation data set level. Here, if we have more samples, the AUC is getting higher for detecting CI-DME with center point thickness more than 250 microns. This is the same as the detection of the subretinal fluid. For summary, deep learning can potentially be used for predicting CI-DME based on OCT data from color contrast photography and color contrast photography images from either treated or naive cases of DME, like in the IOVS paper, may be used for training and for intervalidation with high acceptable accuracy. And The new AI model developed for OCT data is shown to have higher accuracy than even retinal specialists, creating the same set of color contrast images for predicting CI-DME. I think for detecting CI-DME, well, the model of choice should be trained with OCT data, not from the color contrast images. And I'd like to thank you, all the team here. Well, I'd like to thank Pinal. Pinal may be one who sits in the audience here, who will write a code for this algorithm, and the Google team that we work closely. But again, I'm not an employee of Google. I'm not. And here our team here in Thailand as well. Thank you very much for your attention. Thank you.